please welcome Cathy Monkley. We're going to march soon, don't worry.
Wow! Well, looking at you, there's so many people here. You can see when you stand up here, and it's fantastic. Thank you so much for coming, all of you. I wish I could count you, but I can't. It's great. Lovely to have you with us. Now, I was supposed to be saying a few words about the science behind climate change and mass extinction, but you know, I found it so hard. My living room is covered with bits of article and notes written on bits of paper, and I really couldn't decide what to do. Was I to explain why Donald Trump is wrong when he sort of gets muddled between weather and climate? He looks outside and, oh dear, it's cold, so what's happened to climate change? Well, weather and climate are not the same thing. The weather is what you see outside the window and what you feel when you go out. The climate is what's averaged over a large area and a large period of time. They're not the same thing. So I decided not to tell you that, but I have anyway. So I'm going to, something else I decided, and I made a demonstration on one of these flagpoles, because it's easy to hear the statistic that prior to the Industrial Revolution in this country, the global amount of carbon dioxide in the atmosphere was 280 parts per million, and now it's 410. But it's very difficult to see what that looks like. So I got a flagpole, and 280 parts per million comes up to about my middle. 410 parts per million was up to my nose. So we've done an enormous amount to the climate since the beginning of the Industrial Revolution. The other greenhouse gas that is extremely important that you don't hear so much about is methane. And the increase in methane since the beginning of the Industrial Revolution has been far, far greater. It's a bit difficult to get consistent figures, but around 790 parts per billion methane in the atmosphere prior to the Industrial Revolution, and now that's gone up to 1,850. So that's over double. Now the two gases work differently. Carbon dioxide stays in the atmosphere for a very, very, very long time. So the carbon dioxide that we've got up there now is going to still be there in hundreds of years' time, still increasing the temperature. Methane works differently. It's a much shorter-lived greenhouse gas, but at the beginning it is very, very, very much more powerful. So it doesn't stay there long, but in the near term it works like stink, and it's very, very powerful. And fracking is one way that we are increasing the methane in our atmosphere, because the gas that they are fracking for is natural gas, which is methane, and it leaks. It leaks from the wells, it leaks from the pipes, it leaks all the way along the line. So that's one way we're increasing it. Another is that climate change itself is increasing the temperature, and what does that do to the ice? It melts the ice. You melt the ice, then you have less ice, you have more dark water. White reflects the sunlight, the dark absorbs it, so the water gets warmer. So that's another way of doing it. And there are methane clathrates, which are frozen ice-like structures of methane under the ocean. And as the ocean warms, they start to be released, they start to bubble. The permafrost is melting, and it's releasing methane, and it's releasing carbon dioxide. Permafrost is supposed to be permanent, and it's not any longer. We've destabilized it, and there are lakes in the Arctic and places that are bubbling. There's a few interesting statistics that might come out. Yesterday there was an earthquake in where was it?
There were
Alaska.
two.
Thank you. It was in Alaska. It was a magnitude 7 earthquake. Now, I always used to think, I wish people wouldn't confuse earthquakes with climate change, because there's no connection. But recently, the reading I've been doing is that some of them are connected. Because if you destabilize if you destabilize the permafrost and you melt the ice, you release the water from it, you're changing the pressure on top of these frozen, the frozen clathrates underneath, and you're also altering the pressure on the fault lines. So there are possibilities that some earthquakes now can be contributed to by climate change. Two other things that I just want to mention that really struck home to me, recent articles. One is that the giraffes are now endangered on the endangered list, which is horrendous. And salmon, the salmon season in Scotland, people who wish to catch these things, there has been practically none to catch this year. So you look at the top species and then you look at why. Climate change itself may be one reason, habitat loss may be one reason, pollution may be one reason, but one really, really, really basic reason goes back to what Sasha was saying. What they eat is disappearing. If you eat frogs and the frogs eat bugs and there are no bugs, then there's no frogs and then you can't have anything to eat. And that is happening all over. It's happening on the earth, the land. It's also happening in the ocean. The baseline of ocean life is the plankton. We're acidifying the ocean, we're killing the plankton, we're killing the fish, we're killing everything that eats the fish. And we are animals too. We eat fish. Don't need to say any more. Thank you for coming.